Hi everyone. We're going to start the session now. And firstly, I would like to say good afternoon and welcome to everyone. And thank you for joining us today for this industrial empowerment series titled Illuminating Our Nation with Solar Lightings, an Inevitable Journey. This will be a great opportunity for us to gain valuable insights and learn from our distinguished industry experts. Okay, for those of you who doesn't know me, my name is Lian Michael, advisor for the IEM student chapter at UOW Malaysia KDU. In getting this session going, firstly, let me introduce you to our moderators for this industrial empowerment series. Firstly, we have IRTS Ainon Shakila Shamsuddin, who is a lecturer at School of Engineering. She is a passionate and committed academic with over 6 years of experience in our institution. Her expertise revolves on power, electrical, and renewable energy, and has 17 years of experience in the industry under her belt. Together with her is Mr. Vishallan Thabonithi, the Vice President for IEM Student Chapter at UOW Malaysia KDU, and a budding engineer enrolled in our Bachelor of Mechanical Engineering with Honours Program. Okay, and before passing the stage to our moderators, I would like to inform you that to ensure clear communication, we have muted your microphone. Alternatively, you may post your question on the chat box to source your question. Yeah? We have the support team to pick up the question and post it to our industry expert. This online session also will be recorded and made available at our YouTube channel named SOE UOW Malaysia KDU. There will also be a photo session at the end of today's series, so please be sure to turn on your camera. Yeah? Okay, and to commence our session, I would like to invite IRTS Ainon to introduce our distinguished industry guests. And over to you, IRTS Ainon. Thank you.
Thank you, Michael. Assalamualaikum and a very good afternoon. Thank you all for joining this event. Today, we have two amazing speakers from local and international. Firstly, we are pleased to welcome our first speaker, Mr. Matanda Mwewa, President of the Solar Industry Association of Zambia. Mr. Matanda is a keen supporter of renewable energy, as well as an ambassador and advocate for green energy solutions. Mr. Matanda realizes that by staying up to date on the latest developments in the renewable sector, he can make a significant contribution to sub-Saharan Africans' national and regional crisis. He also believes that increased sustainable energy technologies in the overall energy supply system are critical components that should be included in any country's national energy plan or policy. Mr. Matanda holds a Bachelor of Science degree and a Master of Science in Project Management from Copperbelt University, and also finalizing a Master in Renewable Energy Engineering at the University of Zambia. Sits on National Energy Technical Working Group and is currently the President of Solar Industry Association of Zambia. He has 9 years plus post-qualification experience in renewable energy applications, such as solar-powered lighting in field locations, designing solar system sales, marketing, managing projects, development of businesses, and staff management duties in various renewable energy companies. Mr. Matanda, we are happy to have you here today. We are also pleased to welcome our second speaker, Mr. John Chew, Director of Luminance Systems Negeri Berhad. Mr. John Chew specializes in the lighting and IoT industry with experience in its design, application, and engineering. He is passionate about creating value using innovative techniques, methods, and tools that revolve around process, systems, products, and lighting. He provides training and education to designers, architects, and engineers on creating innovative designs that are functional and meet business applications. He has developed applications for various industries such as SMEs, retail, FMCG, engineering, and finance. He is currently overseeing Luminous System, a lighting manufacturing company, and Sense Advisory, which does technical consulting for its clients. He holds an MBA from the University of Hertfordshire and degree in engineering from Deakin University, and is an active participating KDU UOW alumni member. It is really great to have both of you today to share your knowledge regarding solar powered energy. Welcome.
Hi everyone, good afternoon. First of all, I'd like to thank Mr. Michael and Ms. Ainon for that amazing introduction. For those who have never seen me before, hi, my name is Vishallan. You're another half of a moderator for today's session. And I want to thank every single one of you who are here today, taking your time to be with us for today's session. And for those who have seen me before, all I can say is you get to see me again. So let's not waste any time. And I would like to start the first part for today's session. Good afternoon, Mr. Matanda. Hope you are doing well, by the way. So, Mr. Matanda, basically, when the first time I was going through your profile, the first thing that caught my eye when I was going through your profile and stuff, I found out that you were the president of the Solar Industry Association of Zambia. To be really honest, that caught me off guard, and it really picked up few interests among my friends at this university and also few lecturers. So what we would like to know is, what is the story behind you becoming the president of the solar industry back in Zambia? I believe there are a few pathways that you have taken to eventually bring you here as the president of the solar industry. Not only that, we would like to also know that solar energy itself is a renewable energy. And we want to know what are the challenges it took for you to start up a solar power plant back in Zambia. And not only that, if it's possible, share a bit of the technology behind the solar power system that you have worked with. What do I mean by technology? What goes behind the scene? What it takes for someone to come out with a solar power system, and so on. And with that, I would like to pass today's session to Mr. Matanda and the screen as well. Thank you, everyone.
Okay. Can you hear me? Okay, that's good. Thank you, Vishallan. First of all, it's an honor to be part of this industry empowerment series. It's an honor, very, very an honor. The association and probably the people of Zambia are glad that we can be part of this and just share our knowledge from the industry's perspective in Zambia. Yeah, so to dive into this series, let me share my screen so that I can just give a bit of a background on how I started and where I'm coming from. I'm sure you can see my screen, right? Can you see my screen? Okay, perfect. All right. Okay, so to begin, I don't know. Okay, yeah, thank you. So my name is Matanda Mwewa. I'm basically the board president for the Solar Industry Association of Zambia. I've been on this post for 2 years now. I was elected in 2021 last year, at the beginning of the year, January, and this is my second year running. Just to give you a bit of background, so I developed interest in renewable energy back in 2011 when I was in my third year studying at the Copperbelt University. What really spiked my interest was that I remember I used to have a very close relationship with one of my lecturers who gave me sort of a hint where the world was going. And I picked that interest and started seeing or reading about renewable energy at large. And from there, I just developed this interest in this technology, and I knew exactly what I wanted to do after university. And so when I graduated, my first job basically was under a company called Solar 8. They are headquartered in the UK, have a company here as well in Zambia. So their main focus basically was to alleviate poverty through the distribution of solar lights in Kiro, Zambia, small lights that are distributed for teachers, students, people that do not have connection to the grid. And from there, after 2 years, I moved on and joined a company called Mohanya Solar. With Mohanya Solar, it became a bit of a different type of technology because now I had to learn how to size up inverters, what the solar panel basically was, the sizes, differences that were there, backup power systems, off-grid system, on-grid systems, and this is where now I transitioned to actually learn more about solar. From there, I was later on worked by a company called LiQWYD, who are basically into distribution of solar equipment, solar panels, inverters, batteries, name them. Then I transitioned again, and now I was with JS Solar. I was basically a sales manager there. And yeah, my job there basically was to look for projects in the region that are being developed, megawatt projects, 5 megawatts, 30 megawatts, huge projects. And because of my experience in the sector, I became very close with industry players, and I knew exactly what was happening from the ground to basically what government was doing. And so players in the sector thought I should vie for the presidency, and I did. And that's how I was elected to being the president of the Solar Industry Association in 2021. So that's basically my journey in becoming the president. I also obviously advanced myself in attending a master's in project management so that I could understand the project aspects from initiation to close out in terms of projects. Then later on, I also thought it would be very important for me to have at master's level a renewable energy a paper that could actually validate my authority in the industry. Yeah, so to jump on to the next question, challenges. It's quite very interesting on so many levels, especially when you look at world over, but I'll dive straight into the Zambian context. So with the Zambian context, what the issue is that we have these challenges, which is basically access to finance, regulatory barriers, lack of information. If I was to expand more on access to finance, you would agree with me that the renewable energy sector world over is a new sort of sector. And so for Zambia as well, it is really at its infant stage. So mostly the companies that are coming on board are SMEs, so to say. And you find that they're having a challenge when it comes to accessing finance to finance their businesses, finance their projects. And also there are also regulatory barriers. With regulatory barriers, you find that the policies that are being put in place that do not really push the agenda, or the other thing that you find is that certain policies are not in place to actually push these technologies. So it's really sort of bottleneck issues that are being solved or resolved as we go. Government is really interested in this area, and we're glad that we're actually receiving support from them to see that some of these things are actually removed to enhance the sector. And the other thing is lack of information. If, for example, Vishallan, you came to Zambia and you wanted to set up a plant or you wanted to start up a business, it would be very difficult for you to find exactly the numbers. For example, if you wanted to set up a solar power plant somewhere in the rural areas, the numbers are not there in terms of probably the number of social amenities that are there that need your facilities. So it's quite challenging in that regard. And I know government has set up certain initiatives to ensure that that information is provided to investors that are coming into Zambia, as well as any individual that would like to actually have a project or probably run a company in Zambia. So that's kind of a bit of what issues basically our people in Zambia are facing, or companies, so to say. Yeah, I don't know if you asked me about power solar systems, but maybe just to explain a what power solar systems are. I hope I'm not going ahead of the conversation, but just to explain a bit, I'm sure you can see on my screen here, there are a few pictures that I've just put on. These are some of the projects that I've participated on, or probably I've been directly linked to. So just to explain on a solar power system, the solar power system or power solar systems are made up of solar panels, inverters, and batteries. These are the main components of a solar system. There are small items like cables, breakers that come into play. But when you're looking at a solar power system, you find that solar panels will be there, an inverter should be there, and batteries should be there. So basically, this system works from sunlight, which is converted to electrical energy using what we're calling PV or photovoltaic equipment. So the energy is used to generate electricity or can be stored in batteries. As you can see, I have a small solar plant there. Batteries, these are gel batteries, but now the technology has moved. As you can see, there's some lithium-ion batteries that are on the ground
Excuse me,
there.
sir,
And these are
sorry to interrupt. I
Yep.
think you're not sharing your screen. We are just seeing the first slide.
Really?
Yeah.
Oh, that's odd because I have moved. Let me see.
Okay, now it's moving.
Now it's moving. Yes,
Okay.
correct.
Yeah. Now we
Okay.
are at the third slide. Yeah. Thank you.
Yeah.
Thank you, Mr. Matanda.
Yeah, so I was just saying that these are some of the products that are, or the equipment that we use in Zambia. I know regions differ in terms of which kind of brands that they have. But then just to mention some of the brands, this is a Victron inverter, this is an SMA inverter, these are Pylontech batteries. On the gel batteries, these are Shuret batteries. They come from the USA. We've got a Magnum inverter there. Then I'm not sure what brand of solar panels these are, but yeah, those are solar panels. So yeah, I think that's what I can say for now.
Thank you, Mr. Matanda. Actually, when you told at the beginning, when you were the third year student and you found the passion in solar energy, it really hit me because I'm in my third year right now and I'm still
Really?
finding what's my passion. Yeah, I have another year left. So I'm still finding what's my passion. Hopefully, after today, we can share the same passion in solar as well. And maybe we can meet up one day. Maybe you come here to Malaysia and I come to Zambia. It was really insightful and thank you for that.
Definitely. Thank you. Okay.
That's great, Mr. Matanda. Okay, let's move into Mr. John. Okay, Mr.
Hi.
John, as an industrial expert, Mr. John Chu, can you give us a short background overview, your journey of becoming the director at Luminance System? What are your career goals in solar powered lightings? Maybe you can share with us in terms of various technologies and its benefit to the consumers. I'll pass to you, Mr. John.
Sure. Thank you so much, IRTS Ainon. Good afternoon, everyone. I think it's definitely a pleasure and honor today to be invited for this industrial series talk show. What I would like to share, how I became an engineer and how, we founded Luminance Systems. So as an engineer, I'm always very fascinated with products and systems and how it is being made. Let me just share you a short story. Or even when I was when I was small, I was always love to break things open and see how small little things would function to produce the final product. Very similar to my dad. He was always a handyman and having good skills with his hands. So for me, if there's any items in the house which may be faulty, I would say, hey ba, hey ma, I'll be the first one to volunteer up and to see how it could be repaired. Sometimes there are some situations, if it's faulty, I'll try to break open up. And sometimes worst thing is that when it is not faulty and I have the curiosity in me, I will try to open it up. But that's always where the problem starts. When things are not, when things is not faulty, I try to open up and I couldn't put it back together. So sometimes I do tell my parents, hey, I think it's faulty. So, I couldn't get it back up and running, So I have a very strong interest in products and electronics. And of course, after my high school I quickly knew what I really wanted. I studied engineering in KDU. Now it's KDU and graduated with Deakin University. So after graduating from Deakin University, I spent 3 years as an electronics engineer. So from there, during the course of work, I would design printed circuit boards. Let's say my management would tell me, hey, Don, I would like to have this automation to do this and to do that. So what I would do is that I would try to, use the use of some microcontrollers, some electronics knowledge we have. We build the circuits, we build the printed circuit boards and implement in the systems. So after that, I spent 5 years as a consulting engineer for infrastructure projects. From there, I've managed projects, contracts, especially in Philippines and in Thailand and Malaysia. So for that 5 years of doing consulting engineer, I also, at the same time, I also taken my MBA course just to increase my exposure in business and entrepreneurship. So, however, after spending around 5 years of doing this, I'm still, my passion is still product development and systems. So one thing I got some passion about is especially on lightings. So why lightings became my interest is because I realized lightings changes the way we see things. So whenever any spaces whereby if there's human, there's definitely is lightings, So whenever there's lightings, there's definitely have humans. So I venture very much into it, studying the details onto it, and I feel, through lighting, it changes the perception of our views. And most of the times, when lightings are placed properly, it creates proper emotions. So after that, I've founded Luminance Systems together with a partner of mine, and I've spent 11 years as an engineer to develop lighting products for the home, commercial, and industrial projects. Talking about what we do in Luminance Systems, we practically design, manufacture, and supply lightings for home, commercial, industrial. We also a Philips OEM partner, whereby they supply us components, and we'll assemble it, and we deliver the full product to the customer. Of course, the reason why also they selected us as an OEM partner is because me and along with some engineers, we have the technical expertise to design the product, to assemble the product, and and that is actually very much needed in the industry. Is because especially for commercial industrial projects, a lot of clients would require that the lightings are not somewhat consumable, but somewhat serviceable. So when lightings do fail, they would sometimes come back to us and say, hey, Don, how could we fix this lighting, fix this product? A lot of, if let's say traders or they tell them, just throw it away, buy a new one, but that's not sustainable. I think that's not sustainable anymore. So what we always do is that whenever they purchase the product, we will go into say, hey, say example, if there's a particular part which is faulty, you could change the particular component. So you could save on the particular part. Okay. So what the products which we, maybe I just give a brief overview of what type of products we do in luminescence. We do downlight, spotlight, street lighting, and of course the talk of today, solar lighting itself. Okay. Of course, solar lighting, from 11 years ago compared to now, it evolved a lot. Last time, we've used very conventional. Maybe later I don't want to jump the gun. I would give you some details on later in my presentation. But last time was a bit more conventional, but now is how to call it? We all call it all-in-one solar lighting. So I would later share some details with you, and all the participants. So basically, I think that's all. Maybe later I will share some details on how the application, the design, and the moving forward for solar lightings. Thank you.
Thank you, Mr. Don. That was a great sharing, Mr. Don. I hope it will give a good motivation and inspiration to our students, not only study for past exam, but take the opportunity to love engineering. Great.
Okay, we love, yes.
Thank you, Ms. Ainon and Mr. Don. But now let's get back to Mr. Matanda. So, Mr. Matanda, when you were sharing during the first part of the session, it really showed that you have a lot of experience with you on your respective field. And I believe you have involved yourself in many multiple projects back in Zambia. And with your experience on the field, I believe you have faced quite a number of challenges, maybe back in Zambia and also other countries. And the one thing that is in my head is for countries that have different climates. What if that country doesn't get enough sunlight? How do you face those kind of problems? And if it's possible, please share to us about what the new technology right now is going on in the world about solar energy, maybe back in Zambia or in other countries as well. And with that, I'll pass it to you.
Okay, thank you, Vishallan. Yeah, quite interesting questions there. If I can get back to my screen, let me see if I can share again. Okay, can you see my screen? Okay, perfect.
Yes,
so maybe just starting with projects. Let me say, first of all, give an oversight of, especially when it comes to probably the world over the sub-Saharan Africa and the status quo. I'm sure you're aware that we have about 1 billion people that are not connected to or don't have access to electricity. And when I come to my local area on the African continent, we have about 600 million people across the sub-Saharan Africa that live without electricity. And when you get down to Zambia, I think I'll share more about that in my next slide. You'll find that we only have about 5% of our rural areas, or 4%, 4 to 5% of our rural areas that are connected to the grid. And in the urban settings, about 67%. So overall, we have about 37% connection rate or electricity access to the people that have access. So the challenges that have been or that I've seen around in this sector is that, like I alluded to earlier, is the political situation probably for each and every country. This may be the Western countries, Eastern countries, as well as Africa. I'm sure you've heard certain prominent people in the world that say climate change is a hoax. So if you have a prominent person who's making decisions in that regard, you find that they won't pay attention to issues to do with probably climate change or pushing the agenda of solar in that regard. Other issues that have been noted is that since this is a new technology, there's no capacity to handle certain projects or to come up with certain business model that work for your country, because you cannot borrow certain business models that work, for example, in Eastern Africa, and you bring them into Southern Africa. Obviously, dynamics change there, so you have to really go down and see what's really happening and tailor your business model to the population or to the economics of the country. So there are those situations about capacity, knowledge. Our banks, for example, in the Zambian context at the moment, financing renewable energies is far-fetched. The interest rates are just out of this world. So, and the reason is basically there is high sort of perceived risk when it comes to renewable energies or solar, so to say. So there are these issues that we're trying to still solve, and this is similar to other countries, but South Africa is different. They are moving at a very fast pace. But when you look at countries like Zambia, Zimbabwe, Malawi, Namibia, it's more like they're all in the same kind of bottle. And also the major issue when it comes to what we're talking about today, which is lighting, what we've noticed in the Zambian context is affordability issues. So you see that 54 to 60% of the Zambians are actually living in rural areas, and they have less purchasing power. So if you take a system and you want to sell it to them, you have to look at how can they afford or is it possible for them to afford? So you need to look at those dynamics in order for a business to thrive and just basically push this agenda, because there's also this issue: if you do not pay for something, you won't take care of it. So you have to at least give them that sense of ownership. We understand that there are projects going around that are actually donating these lights, but studies show that for someone to own up something, there's supposed to be some sort of sense of ownership. They have to pay just a tiny sort of probably dollar to each so that they can feel that pain and probably take care of it. Yeah, so I know I spoke about my experience, but I thought of highlighting sort of projects that I've actually uh, been on. When you look at, for example, Solar Aid, where I was working in 2014, 2015, we mostly concentrated on decentralized solutions and specifically Pico solar lights, which I believe my colleague, Mr. Don, will talk more about because he's very experienced in that area, sorry. So the least cost, decentralized solutions basically are the least cost way to provide power, gaining access. And you see that there's a vision across the region. By 2030, we should have hit these numbers. By 2030, we should have hit these numbers. And
Mr. Matanda, you are muted.
He got muted.
Hello, Mr. Matanda.
Hello.
Okay, now you're back. Yeah, you're back.
Okay. All right. Okay. Where was I?
You
Hello?
were at the solar right down there, below solar right?
Okay, yeah. So I was saying that studies show about 5 million people have gained access through solar home systems. And for me in Zambia as well, Solar Aid was able to go into the deepest rural areas where it was very difficult for you to actually access or get to the people. As you can see, the first picture there, that's one of the solar lights that we would distribute in these areas. That's a D-Light S2. It's a very small light, about 20 lumens. And this was known to be the fastest selling light because a student could buy that for about, that time I think was $10. And it would light up probably 4 to 6 hours. And that would be enough time for them to study and do something at night.
Hi, Mr. Matanda.
Yeah.
Yeah, is it some lights that they hang it just on the ceiling? Is that or it's
Yes,
just it's a
yes.
table lamp, I assume?
Yeah, so the way it's been made, as you can see on the stand here, you can actually hang it or you can put it on the table. So at the
interesting.
back, yeah, at the back there's a solar panel. Then behind there's a light, which would have about 20, equivalent to 20 lumens or 20 candles put in a room. So it was very interesting, and this really changed my perception on how I was viewing the rural setup, and people really need these lightings. Yeah, and other installations that I did were under Mahanya Solar were basically installations of off-grid and on-grid solutions, water pumping systems, and mini grids. As you can see here on the picture, this was at an exhibition somewhere in central Zambia, it should be the largest farm block that we have in the country. And people are really keen when it comes to water pumping systems. Yeah, under SolarQuest, it was just basically distribution of solar equipment. And one notable project that we did was under an NGO called Women for Change, was an irrigation system. As you can see on my far right down there, this was a solar water pumping system for about 5 to 20 hectares of irrigation. And we actually empowered women in the rural setup to actually do some irrigation and horticulture products out there. And this is still working, by the way. We did this in 2019, and they're still using it up to today without actually paying anything. So these are some of the issues or some of the projects that I've participated on. And when you talk about climate, I know you mentioned that this is something really interesting to you. Technology is really advancing, and what's happening right now is that each region has some sort of specific technology aligned to them. Quite right. When you look at a solar panel, it's been made in such a way that it's able to actually go in each and every region, but mostly when you look at the efficiencies, they've increased from, if you look at the efficiency from, for example, in the 1990 to date, the efficiency has really increased, and the reason is basically that regions have different climate characteristics, and for that people ensure or designers or engineers ensure that we have equipment that works for the most harsh conditions that this equipment can actually go to. I have seen batteries that can work in the coldest regions like the South Pole or the North Pole. I have seen panels that can work in the hottest regions like the Sahara Desert. So this technology basically is being aligned to what the world's conditions are. I've seen panels work in places where there's cloud cover, but you still generate enough energy to power up a home. So it's really interesting, and yeah, some of the new technologies that are out there is that we have now a floating solar plant. You actually put up a solar plant on a lake or on a sea. That's one of the, I think, highlights that I've seen. I've also seen some sort of technologies that's now being embedded in clothes where you can actually generate energy using fabric. So there's this advancement in technology, but it would be good, since I'm dealing with students, just to go see and read for themselves. When you read for yourself, I think you'll be able to understand more and appreciate the technology and where we're going at the moment. Yeah, so I think answering your question, I think that's it for now. Unless there's any other additions, Mr. Don, do you have anything?
Yeah. Well, it's very interesting that especially some of the solar applications being applied across your country. I think it is something very maybe it's a different context here. What I'm saying is that like you're saying, for a particular region, you have a specific type of PV which is specially used for that particular climate. So I think that is something interesting. But maybe in Malaysia, maybe the type of PV also could be possibly be different, and the setup could be different. Also possibly due to the sun insolation rays, is also slightly different from country to country.
Yeah, definitely. Yeah. For Zambia, I think we have about 2,000 to 3,000 sunshines per day. And yeah, so for other countries, I know it's less, some it's more. But yeah, because of that, actually, you can use the technology to use it to your advantage, depending on the insulation that you have.
Yeah. So, Mr. Matanda, normally the peak hours per day, normally you get more, I assume maybe around 6 hours. Would that be around that?
Yes, but for design purposes, we use five hours. So textbooks or researchers will say we're in between 4.5 and 6, but usually for Zambia we use 5.
Oh,
especially when you're designing a system for a client, you're better off using 5. That's our safe spot.
Yeah, even I think in Malaysia context also, they will say it's around 4 to 6 peak sun hours. So normally also we use 5 as a buffer, so we don't use 6 also. Yeah.
Wonderful.
Okay, but I think in Zambia, maybe the peak sun hours could be slightly more than Malaysia, I assume. Slightly more could be.
Yeah, I think so. I'll look it up. I think so.
Yeah, good.
Yeah.
Okay.
Yeah, so Vishallan, that's it from me, I think. Yeah, I'll stop sharing now.
All right, going back to Mr. Don, okay, focusing on the technology, right? Surely the audience want to know, what are the latest technology that we are moving towards? And does it consider the environmental sustainability? Is solar the answer for Malaysia to achieve net zero carbon emission by 2050? I think it would be better if you can input to us some challenges that we are facing from the government and competitors' perspective.
Okay. Yes, I think that is a very good macro question. I couldn't answer, I can't represent and answer them as a whole, but what I can see through reports that Malaysia could do it. Why I would say could do it? Okay, I just give an overview on greenhouse gas emissions. What I come to understand from greenhouse gas emissions, 72%, there's a report saying 72% comes from energy production. And despite this, in the report, that is actually the easiest to decarbonize. The reason is because through technology advancement, renewable energy had become a good focus. And if you're speaking on Malaysia context in terms of renewable energy, solar energy is actually covers 90% of 90% of renewable energy comes from solar. Others will become biomass and some other type of renewable energy. So yes, Malaysia is spending a lot on having solar to be implemented here in Malaysia. I think TNB had done. TNB is our local Malaysian electrical grid supplier. I think they've done a good job in having various projects like feed-in tariff, and together with some government organizations such as SEDA, which offer incentives for people who actually invest in solar lightings. So definitely yes. Even I come to understand there's some report that Petronas is and our oil and national oil and gas company within 2035 their target is actually to have a net zero carbon emissions. So I think that definitely that is possible. Yes. And okay, and as also to further explain on especially on solar lighting, maybe I would just to give a preview on some details on how the applications and the design of a solar lighting. Okay, what I do is I will share my screen. Okay, I assume that everyone could see this slide. Okay,
Yes.
so today I will mention I will just give a brief overview on what solar lighting its application, its design, and what we could see the future ahead for solar lightings. Of course, the objective here is to provide a view of solar lighting at a technical perspective and what it could bring us. I will divide the quick brief presentation into three major topics. First of all is the lighting brief, what its benefits, challenges, and its applications. Secondly, what are the key principles and design elements into design of solar lighting? And the third aspect is to actually how we could optimize it more, And this is also a very interesting topic whereby, like what Mr. Matanda has shared, there are certain groups of people that could not have access to solar or solar lighting itself due to its cost, due to its technological advancements. And I think this chapter also we will share possible maybe the future ahead everyone could afford to actually have solar applications within their homes. Amazing solar lighting. Okay, why I would say amazing solar lighting is because just get to know that solar is a natural lighting comes from the sun. Okay, and what we actually do is that we convert that solar into electrical energy, electrical storage and energy, and from the electrical storage, we will actually convert it back to an artificial light. So why I call it amazing is because also it's a light source from another form and a light source which we actually need in another form. Of course, why I call it amazing is that because like while we manufacture lightings, 95%, I mean, most categories of lightings come from the live electrical grid, unlike solar lighting. So you do not need to have an electrical supply to actually supply it. You do not need an electrical supply to actually make it work. So we can know that the solar lighting powered directly from the sun is totally renewable and sustainable, and looking at this aspect is definitely free to use. Free to use, yes. in terms of operation, it's free to use. Of course, there are some challenges like you need to spend more on components to get solar lighting up and installed. The next benefit is that as we know that when we supply lightings, not just in Southeast Asia, we also supply lightings to other parts of the world. We realize that a lot of our electrical components, electro power supply, comes with an electrical voltage, required voltage. Like you can see in various parts of the world, like in America, like in certain parts of Africa, South America, you know, it has different voltages. And if we were to supply lightings to the particular continent, you know, our power supplies must change. But unlike solar lighting is totally all-in-one. Yeah, you do not need to actually take note of whether what type of live electrical supply. You can just get it installed in any parts of the world. But of course, there are some certain parameters that we need to take note of, such as sun rays, the peak number of hours per day you can get from sun. What we realized that through 11 years of having lightings installed, especially for solar lighting, is actually quite easy to install and minimal maintenance needed. You know, like you can see in this quick diagram here, you know, there's a solar panel attached to a particular frame, and the frame attached to a particular pole, and we install some of the light source itself, and we will normally use a crane to actually bring it up. And all this installation, what we realized that through the supplies, and we supply to contractors installing for a particular site, they could, each pole, they could get it installed within 2 or 3 hours. You see, unlike normal conventional street lighting, whereby you need to pull the infrastructure directly to the particular place, which sometimes is not possible for the particular area, and sometimes it's not conducive, and it takes a lot of time. Okay, however, of course, the benefits does not all come without any challenges. Like I mentioned before, it must be exposed to sun, and we must have sufficient solar rays with time needed to charge the batteries. Like you can see in this particular chart, you know, places like, I'm sure like places like Malaysia and Zambia, you know, I think have good amount of solar installation as compared to maybe the Western countries, such as you can see right above, like in Denmark, Poland, and Ukraine, whereby, you know, the colors are highlighted is in slightly green in color. So those have slightly less solar installation as compared to the countries whereby we have darker colors and, you know, darker reds and yellows and oranges. And the next challenge we find is that due to the installation of street light, like I just give example, a solar street lighting, there's definitely higher capital investment due to more components. Like you can see in the middle here, say example, if there's live electrical supply, anyone would want to install electric street lighting would normally have the lighting luminaire, the street light pole, and the footing itself. Unlike if we were to install a solar street lighting, besides the luminaire itself, we will need to have the investment of a solar panel, the battery banks itself, and the solar charge controllers. So all this work in tandem to provide the necessary supply to the solar street lighting. So the next challenges also is actually the application and output of light are determined by the individual components. Okay, the reason why we say that is that, say example, you have a particular application. Okay, that particular application needs a specific power output and a specific usage duration. So if let's say the power output is low, say on 40, maybe, you know, say example, you have a street lighting of only maybe 40 or 60 watts, which is considerably low. You have a standard size of solar panel, standard size of what do you call the battery banks, and of course the solar charge controllers. However, if you actually double the power output and you actually increase the usage duration, the size of the solar panels increase significantly. the battery banks itself also increase significantly. So with increase in size and capacity, of course, there comes the increase in cost of having such systems to be installed. Next, I would like to maybe share, what are the basic applications normally that comes with solar lighting. These are some products which is somewhat relatively simple, easy to install. Say example, the one on the left is like a solar floodlight, which anyone could just buy off the shelf, put it on their roofs, and activate the solar floodlight wherever they want. There are also some, like in the middle here, you can see there are solar garden lights, whereby I'm very sure some people who have their garden in their homes, but they do not want to pull electrical live wires to that particular area, and because they find it is somewhat not convenient, or the supply is not available, they will normally use such products like this. Products like this, I know this is also a particular product from Philips, whereby you could actually buy this off the shelf, install it to the wall. So whenever there's anyone who were to pass by, the infrared sensor will detect and will actually switch on the lights itself. And everything is powered by the solar panels and the batteries inside. Okay. And let's us move to the somewhat for commercial application. Sorry. For commercial application, normally we see that we have supplied this generally for street lighting, for passageway lighting, and for like gardens. Like you can see that in this particular area here, for solar lighting, you realize that the solar panels get a bit bigger and bigger depending on the application used, especially for roadway and roadways which or highways which is used by vehicles. Definitely the type of power of lighting output would significantly be higher, and of course the size of the batteries and the solar panels will be bigger. Unlike if this is to install on a garden, on a public park or something like that, the output may not be no need to be too high, and hence the solar panels could be slightly smaller, and the light output could be even less. So this makes the product and the physical aspect a bit much more compact. Okay. Next, I would like to maybe bring some thoughts on the principles and design on how we actually design the solar lighting. The next, like what Mr. Matanda had also mentioned previously, is that all components of solar lighting, so whether solar application comes to all of this, these are the few basic key components. First of all, you definitely have the solar panel. Then you have the solar charge controllers, the batteries, and the loads itself. So the solar panels, whenever it's actually placed and whenever it reaches the peak sun hours, you actually supply the necessary current to the solar charge controllers, which in then charges the batteries, stores the battery at a particular time and date. So whenever the load or the lighting is needed, whenever it's activated, the solar charge controller will actually supplies the necessary current, voltage and current to the particular load from the necessary input from the battery itself. So for any solar lighting applications, it comes down to all these four components only. Next, I will just give a very typical example of how we actually design this for a particular application. First of all, to design this is solar lighting, is that we will need to know what is the application used for and where is the lighting being used. So like for this example, say example, we use it in a public park. We will say that, we would like to use a particular garden lighting which rated at 80 watts. 80 watts is for street lighting is relatively low. However, it's very suitable for public parks. Not so suitable for roadways and highways because the higher levels of luminance is required. Next, based on the selected particular lighting's power, we will then select what we will actually calculate the current required by the lighting itself. You can see the battery packs. If let's say most of the battery packs we should use is actually 12 volts, what we do is that, we'll get current from the power P equal VI division. We should get 6.7 amps. So what do you mean by 6.7 amps? But what I mean is that if this street lighting, this particular lighting is to operate for a particular hour, it requires 6.7 amps to actually operate this lighting from a 12-volt battery. So next, what we do is that we will actually get the usage requirements. Say, example, for most lightings, we will use it from 7 p.m. to the 7 a.m. the next day. So like from 7 p.m. to 12 midnight, let's say we use 100% amount of output of power. We will use, say, it's 5 hours. Then from from the midnight to 5 a.m., we will have some electronics to be installed, whereby since there's low capacity, there's no such people to walk by. So what we can do is actually reduce the amount of power to a 50% of light output. So from 5 hours, we could actually reduce to use only 2.5 hours. And for 5 to 7, you actually get 2 hours. So in totality, a day would use, say, example of 9.5 hours. Then the next day, the next thing that we need to take note is that how many days of autonomy that is required. The days of autonomy required is say example that particular days that you do not have sun, the lighting will still work. You will still able to provide output. So we need to take note of these parameters when we actually design a solar lighting application. First of all, get to note also the number of usage hours per day and the days of autonomy required by the client.
Mr. Don, that's
Yes.
quite interesting.
Yeah. Yes.
In your design aspect, do you also, I've noticed in Zambia we have lights that actually have some sort of motion sensors, which help probably maybe if there's no one in that area, it will just light up to a certain level of illumination. But then if someone walks by, it brightens up. Is that something also you consider in your designs?
Yes, very true, Mr. Matanda. Like very similar, like the slide which I've just seen here. From midnight to 5, from midnight to 5 a.m. If there's no one were to walk by or no one were to pass, say example, you could set it at 50%. But if let's say that someone were to pass by, and we will have installed infrared sensor to detect, there's someone passing by or there's a vehicle pass by. What we will do is that we will increase it to 100% capacity output. Then let's say within 10 minutes, if there's still there's no one were to pass by, we will actually reduce it back to 50%. So yeah, so that definitely, like Mr. Bana, the concept is correct, because the way we do this to detect the vehicles or the public people is just to actually to conserve the battery as much as possible and to optimize the application itself. Yeah,
100%. That's good. Okay.
Okay, and the next is actually we also need to calculate the battery capacity. Like just now, we've do a sample that we need 9.5 hours a day. The numbers of autonomy needed by the application, say example, is 3 days. From the current from the current required by the lighting itself is 6.7 amps, and we will need to actually multiply with the efficiency. Of course, all in all, electronics doesn't work at 100% efficiency, so we need to put a buffer of maybe 80% efficiency, and from that we actually will calculate 200. From this particular example, we're able to detect around 239 amps hours required for a particular battery. So whenever you select a battery, say you need to tell the battery supplier, say, hey, for my application, I need at least 239 amps hour for my particular application. So with that, it depends on how many battery packs you were to install. If this, if our suppliers mentioned each battery pack, it comes in pre-sealed at 12 volts, it comes at 60 amp hours. So what we will do is that we will know that to achieve 239, we have at least 4 times of this 60 mAh battery packs to be installed within the system to meet the application.
Interesting.
Yeah.
Before we move to the next slide,
Yeah.
I would like to know, in terms of battery technology, what type of battery technology is used? Is it lithium? Is it lead acid?
Yeah, very interesting. Actually, 11 years back, when we first started out, we've been approached by clients say they would like to install solar lightings for that particular area, whereby they do not have any electrical power supply. So at that time, 11 years ago, the common ones used are the lead acid battery. So lead acid battery are somewhat the ones which we used in our vehicles. Generally, in most gasoline vehicles, we have a lead acid battery. So we will actually use that. At those times, what we do when a customer want to have a solar lighting application, we'll build up a box, a metal box. We all call it a metal enclosure, and we store all the lead acid batteries inside, just to achieve the particular number of amp hours. And of course, through time, a year of year, at that we have the introduction of lithium magnesium phosphate battery. In short, they call it LiFePO4. This type of lithium batteries are very compact. Generally used also even now in electric vehicles. It's compact. Is able to store high amounts of storage. And more importantly, as compared to lead acid batteries, the durability, the decay of storage is so much far significantly better than a lead acid battery. Reason why this type of lithium batteries could have high charge and discharge cycles. This is needed. Why? Is because like you can see in solar lighting applications, whenever, say example, if you design for 3 days autonomy, if you were to have no sunlight for, let's say, 1 or 2 days due to bad weather or something, you will actually discharge the battery down to maybe 20 to 30%. And the next day when the sun come out, you need to charge it back to 100%. For lithium batteries is fine, but however, it does have for lead acid batteries, there's a big issue, is because that when you charge and discharge too much, it does not hold, the characteristics is that it does not hold its charges back to its 100%. So it would decay over time. So I think good question, Mr. Maya. You asked we have through evolution of solar street lighting, you have such challenges which we can see ahead for batteries.
Thank you.
Yeah. Okay. And okay. So now we have already done designing the battery banks itself. Like you can see how we also besides the battery banks, you have selected the particular lighting you need. You have designed. You know that how much battery capacity you need. Okay. So the third one is actually the solar panel sizing. So we still based on the particular requirements, usually 9.5 hours operating per day. You have a 6.7 amps required by the lighting itself. We have, say example, we put a solar power buffer of 10%, so we need to increase at least by 10%, and we divide with the number of peak sun hours which we use. So it depends on the particular geographic location of your installation. Maybe like places like Poland, you can see you couldn't use 5 hours. You may only use 2 or 3 hours. Maybe places like from Zambia and Malaysia is almost the same. We can use 5 hours, and you multiply with the solar panel operating voltage, and from there you actually could calculate what is the type of solar panel required. So from this example, we could realize that we can have a 252 watts of solar panel, and the closest of solar panel sizes, you can see you can actually select a 250 watt solar panel for this particular lighting application. So that For solar lighting, that's practically sums up on how we actually design solar lighting applications for our particular for our client. Next, we like to look, what's the future ahead of our solar lightings. Definitely, for all the benefits we have for solar lighting, we there's some challenges, and it's also good that we try to optimize it, solar lighting, to create a sustainable design. Okay, so what we always will try to do is actually to use minimal resources to provide the necessary applications. Lighting levels must be adequate. Why? What I mean to say that is that whenever every lighting applications have a particular standard, we do not want to be you do not be over bright for a particular level for particular areas which you may not need. So what we need to do is that for this particular application, say example is for walkway, for pathway, let's say we only need lux levels of practically 20-30 lux is fine. So what we can do, that we must design specifically for it, but not exceeding it. So with that, the storage and solar panel could be very reduced significantly. So with the design is optimized to use very minimal resources to produce the required output. So a few of the technological advancements which we'll need to look to is actually also on the solar panel efficiency. Like I think what Matanda shared, I think last time, I know we've discussed that, solar panels last time was a very low capacity. I think the efficiency was only like 15% or something like that. I think, Mr. I think you have updated me. I come to understand that it's around at least 25% and above. Correct me if I'm wrong, Mr. Matanda.
Yeah, the technology is moving that way.
Okay.
You're right. Yeah.
So you can see that year and year ahead, efficiency increase could be increased significantly.
Yeah.
Okay.
And I like the fact that you use JS Solar.
Oh, JS Solar. Okay. It's a very popular type of solar panel in your country.
Yeah.
Oh, okay.
Worldwide, actually, it's one of the top AAA rated manufacturers actually in the world. Yeah.
Interesting. Yeah. So I'm sure, I believe that different manufacturers produce different type of efficiencies due to its maybe internal R&D. Is that true?
Exactly. 100%. That's
Okay.
true.
Okay. Then the next, we need to look on this, actually the battery itself. Batteries are getting more efficient, and its capacities increase year on year. Why? Is because not just on solar lighting itself, there's a very huge R&D investments on electric vehicles, and the major components of electric vehicles are the batteries itself. So you can see that various corporations, major corporations around the world, like you can see here, Panasonic, CATL, which supplies to Tesla, BYD, LG, they are increasing their capacity to create better batteries and better output year after year. And you can see on the left graph itself, you realize that the batteries dollar per kilowatt hour actually reduced significantly. And you can see that with the brown line is the density also increased significantly. So with that, I think in the years ahead, whether it's actually solar applications is something that we look forward to. Reason why, the cost could be reduced significantly and definitely be accessible to most parts of the world. And like what I come to understand, Matanda, you have shared that only a specific region could, a particular city could have such application due to its rising costs. So if this, I believe that the cost comes down significantly, I think this could be much more accessible to the public.
Yeah, 100%.
Yeah.
Yeah,
Okay.
and just to add, like you mentioned, I think we've seen a significant reduction in pricing as the technology advances. So yeah, and then in solar lighting, I think one thing we've noticed is that with the type of solar lightings that you have, for example, Pico solar lights, the people that use it actually have more hours of usage when a certain type of battery is used, which is really a plus for them.
Yeah, agree. So even that, I think there's some I think it's also very possible for design, since if over the years the number of hours have increased, so either they have two options: is that the design might not we might not use that much battery. We might use maybe 1/3 of the battery, or maybe less, 1/3 of the battery and maybe a smaller solar panel. So with that, I think the cost also could be reduced significantly. It depends on the application. Unlike now, because due to its certain rated efficiencies, we need to triple the size or whatever the size it is. So but when you increase the size, I believe the cost also increase significantly.
Agreed.
Yeah. And like also to note on this lighting technologies, because why? Especially for solar lighting, if you can look like in this particular graph in 2013, the lumens per watt, you can see that maybe it's possible 89, 80 to 90 lumens per watt. And I believe at that time, at 2013, that is also on a high scale. But you can see year on year is actually increasing. But why? How? You can see even like as of to date for 2022, there's some manufacturers could even claim that they could achieve 220 lumens per watt. That's very high in terms of the lighting industry. But how is this important to the solar lighting itself? Reason why is that if there's higher lumens per watt in the coming years, the current use could be significantly reduced. So with that significantly reduced, the battery capacity invested could be smaller, the solar panels to be even be smaller. So with that, with the reduction of the solar panel sizes, the battery capacities, and the increase in efficiency in its lightings, I think it creates a better compact product, which will be much more accessible to all. And I would like to also share end this with our solar lighting system design evolution. Like you can see on the left side, I think that was used maybe possible around 15 years ago. Very conventional. The batteries could either be you can see on the left here, the batteries could be whether it's inbuilt on the ground or slightly above, just beside the street light pole. I believe at that time there are many reasons to have the battery in the ground or above. Is because possibly in certain parts of our cities or areas, they're prone to pilferage or prone to vandalism. So what we do is that we actually encase the battery inside onto the ground. But however, having batteries onto the ground itself does have its own issues, because places like Southeast Asia, Mr. Matanda, like in our country, is very prone to rain and flood. So with time, 4 to 5 years, water might seep in, and it will spoil the whole system altogether. Okay. So with that, the next generation we can see is that we have normally this. I think this product itself was maybe around 8 to 9 years back. I think what Philips did is that they have the battery to be installed above onto the pole itself. Bear in mind, the sizes actually for this battery is actually like relatively smaller than compared to the many previous years. So what they do is that they've installed the battery onto the pole with the solar panel and the lighting itself. So they have it all in one there. Okay. And with the recent years, I would say, within the 4 to 5 years ago, or or recently, various manufacturers come up various type of products whereby we call it all in ones. Okay. Why we call it all-in-ones is that if you can see in this picture here, this lighting itself, this comes at the back of the lighting itself, it comes with a solar panel. Okay, and with that solar panel inside the enclosure, it does contain the battery itself, the solar charge controllers, and you can see the front here is actually the lighting, the lighting load itself. So everything could be installed in one particular package. Okay, so this type of systems is actually it's not possible 10 to 12 years back. Is because the capacity, the lumens output for the particle lighting could not be achieved at the time. You could not have it so compact. The battery itself is not that compact, and unlike to lithium batteries. And the solar panels itself, now it comes with various sizes that we could have it installed at the back of the lighting. And if you can see on the far right here, a garden lamp pole, you can see, I don't know if you can zoom in and have a look, is that you see the solar panels are actually, is actually so-called encased together with the pole. So you do not see a large solar panel just right above, but rather that is actually encapsulated within the pole itself. So it, in terms of aesthetics, for a particular garden lighting, it definitely looks better. I think as a summary, for all, definitely solar lighting is well needed in the industry, not just only in our parts of the world, in various parts, globally is definitely needed. And definitely, with the advancement of solar panel efficiency, the battery's capacity and its cost if it were to go down, and the efficiency of lighting, with all these three components combined, definitely solar lighting will be accessible to all globally. I think with that, I would like to end my sharing here.
That's very interesting. Maybe just to add on on your last
Yeah.
point. I read somewhere, I think I had mentioned it earlier, that, for example, Zambia, what we're doing right now is that through the Rural Electrification Authority, is that they're extending the grid to some of the most far-fetched areas. But what we've realized is that that is very expensive. And so what government has done is that they've come back on the table and realized to say, well, you know what, the only way that we'll be able to increase energy access is by having decentralized solar lightings or solar systems. So pico solar lights, street lights, and the likes, some of the things that you've just talked about. And I see this as a solution, especially to sub-Saharan Africa. Extending the grid just by 1 kilometer is very expensive. But imagine if you could spend that amount of money distributing equipment like these. And I mean, the lifespan is a no-brainer. So I think that's very important. Yeah. Thank you.
Very true, Mr. Mana. I know it does happen in your country, even in Malaysia itself also. There are certain areas whereby, especially I share one particular project which we did for a Malaysian railway company. They need to have within that railway track, they need to install emergency lightings. So one way to install emergency lightings, these emergency lightings are used, say example, whenever the railway were to stop in the middle of the track. They would require the passengers to come down from the railway track. So with that, due to safety regulations, you need that particular place to be lighted up. Yeah. But at this railway emergency access have the intervals of every 2 kilometers. So being our railway track definitely is long. So having a live electrical supply to every 2 kilometers within the railway track is definitely very expensive. So one of the solutions which they think about is that, hey, why don't we design a particular solar lighting, that activates whenever we detect someone is being used, and if it lights up at night whenever if someone were to use it, we could still use it for the required particular regulatory for the particular application, and definitely it save cost for them, because pulling live electrical grid from the particular station, say example, every 3 kilometers or 4 kilometers is really, really expensive. Very similar to what Mr. Matanda you have shared also. So in our application, sometimes we also do that, saying that it could be we could reduce some costs having such applications to be installed. Yeah. Thank you for sharing, Mr. Matanda. Yeah.
Great input, great input. I believe, right, beside of the technical aspect and electrical design aspect, I believe that infrastructure also needs to be strengthened, right, Mr. Don?
Yes,
Matanda?
yes, definitely. The infrastructure definitely to be strengthened. I would see I mean, in my opinion, in Malaysia context, that a lot of places whereby in Malaysia, like as long as is population there, the cities are there, definitely we'll get live electrical supply. But why sometimes some organization corporation they come to say they chose to have street lighting solar lighting is because when they have certain industrial applications which is particularly remote from the particular area, say example some base stations which is telecommunication towers which is not very accessible to the public. It is located right remotely on the hills. So that's where they would rather use this type of solar lighting applications and not pulling a live electric grid there. So that's one aspect. I think, of course, the second aspect is that a lot of corporations are also going green. I think with all the new ESG governance, I think they are very looking to having a lot of things to be sustainable, having try to reduce as much of carbon, as much gas out emissions to the environment. So that is also one of the aspects that a lot of corporations are looking into solar lighting itself.
Yeah, just to add on, quite similar to what Zambia is doing as well. I mean, I think one of the reports stated that Zambia could only allow up to, I think, 600 megawatts. I think now it's increased to about 1,000 megawatts to its grid. But then when you look at our needs, it's actually more than that. So how are we going to achieve the balance? It's by obviously putting up such systems in far-fetched areas. Yeah. So even infrastructure wise, we may not be there, especially for the sub-Saharan Africa. There's a lot we've lagged behind in terms of infrastructure, and so the only way to actually align ourselves and reach the targets that we want is by having such systems or decentralized systems, solar lighting systems that can actually go in these areas.
Yes, interesting. Yeah. Agree. This type, Mr. Matanda, I want to ask, maybe this type of decentralized systems, normally, I assume that the infrastructure, they will build like a particular building whereby they store all the batteries there. Then, would it be used to then supply to the homes? Is it something like that?
Yes, so these are mini grids. Yeah, so right now actually there is a project that's undergoing, sponsored by the European Union, which is a project called IREP in Zambia. The funding came in for about 200 mini grids that are going to be placed in far-fetched areas. So like you are saying, you have some sort of a containerized solution where an inverter, batteries are put, then probably outside you have a small array of solar panels that then is distributed to a community for them to use for lighting purposes and things like that. So sorry about that. Yeah. So that's something, actually, that's one of the major things that government is trying to push, mini grids.
Interesting.
All right. I'd like to thank you guys so much because I feel I'm learning something new outside of my classroom and textbook. So before I forget, I just want to tell you guys, if you were in a room right now or in a hall, everyone will be giving you a round of applause. And I can't ask them to unmute themselves and start clapping because it will cause a havoc to your earbuds. So what we can do is, can everyone type 111 to show in the chat box to show some appreciation to both our speakers. And generally, thank you, Mr. Don and Mr. Matanda. It's really insightful because as a student, as a young student, I'm CMC 22. I would like the future, maybe year 2030 or 2040, let's say 2050. I would like houses to be developed using solar panels, if you get what I mean. Because nowadays, when they do new housing projects, they don't include solar panels. So maybe the future, if they do include all this, it will be absolutely amazing. And yeah, I want my grandchildren, I don't know, I can't believe I'm saying grandchildren, my future generation to live in a better world with this reusable energy. So before we are moving on to our next section, which is the Q&A. You can see how excited our people are in the call. They have prepared a lot of questions. Oh my God, it's a lot. Okay, let's start with Dhiren. I will throw this question to both of you all. You want any one of you can answer this. So from Dhiren, we have, although solar might be renewable and clean, its wide implementation will require larger scale of usage for batteries, in brackets lithium-ion in particular. Could the negative effect of further increasing demand for lithium-ion battery production potentially outweigh the benefits of solar usage? I will let any one of you to answer that.
Yeah, maybe I just give my point of view on this matter. Yes, what I come to understand that creating solar panels of PV, it comes from ingots, and I think what I come to understand that it uses up a lot of energy just to create these PV panels. But what I can see is that I think like I shared in the report, so 72% of greenhouse gas emissions comes from power creation, so it's very similar for this particular project. But what we can see that that is only a particular point of time. But if you use solar panels which can last 20 to 25 years, when we create such solar panels, I believe, in totality, would still be somewhat positive than its negative aspects of creating gas house emissions. So in my aspect, I think it could still save, and with solar panel efficiency getting better year on year, I think that is something that we can consider, but I believe it will be minimized over throughout the years.
Yeah, I definitely agree with Mr. Don. We're living in a world where there's this, you need to destroy something to make something beneficial in the end, to have something beneficial in the end. So, and unfortunately, that's how science or engineering is. So, like Mr. Don said, we may have to sacrifice a little in order to enjoy the future. So the effects will be minimal, unlike if we continued on the same path. So I definitely agree with what Mr. Don has said.
Yeah. Okay.
All right. Moving on to the second question, I really like this question. Mr. Jeffrey, he said that I understand that Malaysia is amongst the largest producer of solar panels. Why is it still expensive for the common household to go into solar energy?
Oh, okay. I'm not expert on knowing what's the cost of, I know it's still expensive, but what I come to understand from in Malaysia, we do manufacture solar panels, and these solar panels, I come to understand, still of very high quality, and most of these solar panels are also being exported to European and America, whereby there's a lot of tax incentives for them to invest. So, whenever there's some incentives given, the price will still be high. For them is, as a Malaysian context, they could sell the price of selling could still be higher due to the market demand at those countries could still be there. However, if I believe, in the years ahead, if those tax incentives are gradually reduced, and a lot of solar panel manufacturers, they need to compete among themselves, and I think with that, they could actually reduce the price over time.
Yeah, and maybe just a word overview. I think one of my colleagues were discussing why Europe actually has failed, or some sort of Western countries have failed to have large factories is one of the reasons Mr. Don has highlighted too. So incentives as well as probably the raw materials and whatnot. So you find that China has sort of not really monopolized, but they're doing really big on that aspect. So it's very hard to compete with them in terms of placing incentives, them having raw materials and in their factories, and just the labor as well. In Western countries, labor is expensive, but China, labor is very cheap. So some of those factors come into play.
Agree.
Yeah.
I do agree. It's just like I'm sure in a lot of Western African countries, the cost per kilowatt hour is high as compared to our country, to Southeast Asian countries or most probably Zambia. So, the incentives for us to move ahead sometimes a bit different as compared to these countries. These countries, they say that, say example, I've installed these solar panels, I could recoup them within 3 to 4 years or 5 years. It's fine. But in certain parts of the world, we need to wait 20 to 25 years for it to recoup. So and I'm not sure at that time the particular product comes with that particular long warranty. So that comes at the demand at those countries will definitely be higher as compared to some parts of the world. Yeah.
Thanks, Mr. Don and Mr. Matanda. Okay, we have the next question from Hassan, who is my classmate. Hi, Hassan. What is the role of lighting in sustainable development? And can you share with us, based on your experience, how to design sustainable lighting that supports health and wellness while reducing the energy use?
Oh, okay. This is a lighting subject matter. Okay.
Yeah.
Lighting, in my context, even though we could be very technical on lighting, I know we always, when we as engineers, we try to design, what makes a good quality lighting. But in this aspect, sometimes we need to look even at a macro level, meaning that we don't look that technical, but what we do is that we zoom out a bit. We say that we need to create a human-centric lighting. Why? Because whenever there's people, like I mentioned before, whenever there's people, there's definitely be lighting, and when there's lighting, definitely there's people. So lighting is created just for us to use. So in a way that how technical we want to be, we need to come back down to these statements that you must fall back to human-centric lighting. So there's a lot of technological advances, such as we'll call it lighting that tunes to circadian rhythm. Circadian rhythm meaning that, at say example, in the particular morning, the artificial light which you install in your home is somewhat a bit cool. Cool meaning that it's a bit slightly white in color. So over the period of time, say example, when you reach to a particular afternoon or even evening or 3 to 4 p.m., the lighting color temperature from cool daylight will actually transform to a warm white, to create that particular ambience, and which suits to the environment which is similar to the outside. So this type of lighting, say example, if you were to work in a particular factory whereby there's no windows, no nothing, and the lighting only, that's what you see. So that, that lets the user feel that, now I know this is particular. Now it's already evening already, even without for you to look at your watch or your clock. So I think that's something that will affect the health of human beings, and that will improve. We do not want to use artificial lighting all the time, but that will definitely improve on the daily rhythm of moving day to day life. I mean, what I'm saying is that through working, they would know when is the time of the day and when is the time to actually have a break and have a relax. I think that's the thing I want to say.
Okay, maybe we have one more question. Could you please explain more about the grid use in Zambia and if the issue of overload grid is being faced? If yes, please share the ways use to overcome this issue? This is from one of our students, Muhammad Hisham.
Sorry, I didn't get the question.
Okay, I repeat, yeah. Could you please explain more about the grid used in Zambia and
The
if the
grid?
issue, yeah, and if the issue of overload grid is being faced? Meaning, is there any overload voltage? Things like that.
Sorry, okay.
Yeah.
Could you please explain more about the grid used in Zambia and if the issue of overload grid is being faced? Okay, I see the question. Okay, so our grid, at the moment, our grid is only able to, I think, accommodate about between 2,800 megawatts to about 3,000, if I'm not wrong. Overload, I wouldn't really say it's been overloaded. What government right now is trying to do is make it more efficient, and which they have done, I think, in the last 2-3 years. Like I mentioned earlier in our conversation, previously we only had, what was recorded was that we can only load about 600 megawatts more of probably solar or renewable energy to the grid. But as of today, that has increased to about 1,000 megawatts. So you see that they're trying to work towards making it more efficient. So I wouldn't really say it's being overloaded. No, I wouldn't say that. Yeah. So if yes, please share ways used to overcome this issue. Yeah, I think it would have been nice if I had someone from our utility power to explain further, but I think that's the only information I have for you, unfortunately.
It's okay, Mr. Matanda. I want to see you back in Malaysia one day. You come here, bring you, and you can share in the hall. We prepare everything. Bring your friends,
I would
bring
have.
everyone.
Yeah.
Yeah, definitely.
Or we come there. I think maybe there's another
Okay,
possibility.
that's good too.
Either way.
Okay, maybe we have time for one final question. We have it
Yeah.
here from Felix. From your perspective, how does solar energy benefits the low-income economy? And at the same time, what is your idea on bringing the benefits of solar to low-income consumers? It's a good question, Felix. Thank you.
Can I go ahead?
Actually,
Yeah, so in the Zambian perspective, what we noticed was that actually there are figures to this. What we noticed was that in providing solar lighting to low-income houses in the rural setup, what was found was that instead of them using money on kerosene and candle, which then affects their health as well as the environment at large, solar lighting would actually last for probably more than in between, let's say, 4 and 6 years. So in that 4 and 6 years, they'd actually save more money than they would have spent on a candle. An example was given where a person buys a candle with, in dollar terms, probably it would be $1 is about, let me just say maybe 2 cents. They spend about 2 cents per day on that. Over the year, they would have, instead of them buying, if they bought a solar light worth $10, if you do your calculations, you would find actually they would actually have saved more than what they would have spent on them buying kerosene or candles. So in a way, that brings back to them having more money to spend on other necessities. Probably take their children to school or do more farming, buying farming inputs, and probably get more output from what they're doing in terms of farming. Also, just channel that money to other things and them spending it on issues like candles and kerosene. So that's one way solar helps out in low income or for rural areas.
Yeah, that's interesting. Mr. Bana, I think you also did share that if the financing by the government could be very is much more attractive, then everyone could be on board. Like very similar to in our Malaysian context, the cost of installing solar panels at our homes are still not accessible to everyone at the moment. It's not something that we could buy and off the shelf and just get it installed. Is somewhat for us, the cost is something like it's an investment to make. Whether could we recoup it over 5 to 10 years. But I do come to understand that there are some slowly they're coming out with various financing incentives, how to get us on board. So I know if it comes with a very good warranty, attractive financing, then I think more people could afford of this type of technology. Yeah.
Okay, sorry, Mr. Don, Mr. Matanda. I have one more interesting question
Sure.
here. So I want to read it out, yeah?
Yeah.
Okay. This is from PS Win Amirul. He said that we understand that weather is one of the challenges that we need to face when applying solar panels. Since the weather is unpredictable in Malaysia, continuous rain and half of the week might be rain during the day, are solar panels still reliable to use in Malaysia?
Yes. I think one of the I mean, if you are speaking in terms of solar panels for electrical generation, I couldn't represent the whole, but what I know that one of the challenges is called the solar intermittency. So sometimes during the part of day, you couldn't get high output power. So I think this is what currently our national electrical grid facing is that they need to upgrade equipments to solve that because while the load is somewhat consistent, our supply is still is inconsistent if just relying on solar energy. So I think there's somewhat like we need to do somewhat. I think they need to invest in certain hybrid model whereby if the load is high enough, what we need to do, say example, if the renewable like from solar is high enough, they would, will combine it together with their basic electrical supply to supply. But if it's not enough, they will always switch over to the fail-safe method of having electrical supply from the hydro. I mean, that's for solar panels on the electrical side. But if let's say for lightings itself, not an issue like what I've shared. You design based on the numbers of autonomy. For example, if you want that particular lighting, if there's no sun at all, okay, that is somewhat extreme. But if there's no sun for say for 2 days, so you design it for 2 days and you still work. So I think that's how we approach in terms of design for the lighting. Yeah.
Yeah, that's very good. That's excellent. And just to add on, we should understand that solar is all about radiation. So we may have cloud cover, but obviously radiation can hit the panels. So you may not have 100% receiving the sunlight or the intensity that you need, but there should be some sort of radiation hitting the panels, probably for a few, maybe to charge up a bit and maybe your phone, your laptop and whatnot. Yeah, but it does work sometimes. Also, it depends with the type of panels you put up on your roof. We've heard now that monocrystalline panels are more efficient, but anyway, that's another argument for another day. But yeah, so some of those things come into play as well when you're considering putting up a solar system.
Yeah. Agreed.
Thank you so much, Mr. Don and Mr. Matanda, for taking your time and answering this question. I believe there's more questions, but if you guys have any more questions to ask, you can email me personally. Maybe I can ask them later on. And again, thank you for taking your time. The way you both were sharing it, I really can see you guys are passionate with solar energy and solar lighting as well, and we really do appreciate it. And now we have arrived at our photo session. So we have 84 attendees today. Wow, can't believe 84 people today. If it's possible, can I have 84 of you guys to turn on your camera so we can take a photo session together? Come on, guys. Show me your face. Just a quick one. Oh, what is this? Wow. Large gallery with this. Yeah, okay. Smile, everybody. Oh, wait, there's more. Okay. Keep on coming. There's 84 of us. See my friends. Hi, everyone.
Hello.
Okay, smile, everybody. 1, 2, 3. Yeah, one more. Freestyle. No, don't do freestyle. It's okay. 1, 2, 3. All right. Okay, before I pass it to Ms. Ainon for closing, again, I would like to thank every single one of you for being here today. As a student, I really do appreciate everyone taking their time and being here for today's session. And especially Mr. Don and Mr. Matanda, thank you so much. I really hope we can meet one day, especially Mr. Matanda. If you ever come to Malaysia, please do contact me. I can be a very good tour guide. Don't worry.
Yeah.
Right. And with that, I would like to pass it to Ms. Ainon for the closing. Thank you, everyone.
All right. Finally, we come to the end of the talk. Okay. We would like to say thanks again for both presenters, Mr. John and Mr. Matanda, for their informative and interesting talk. And thanks to the audience for active participation. Hopefully today's talk will be beneficial for everyone. Thank you so much for your time and attention. Thank you.